Nanotechnology, the manipulation of matter at the nanoscale, has permeated various fields, and the culinary world is no exception. Cooking with nanomaterials represents a groundbreaking approach that extends beyond the realms of traditional ingredients and methods. This fusion of science and gastronomy has the potential to redefine the way we prepare and consume food. As we delve into the future of nanomaterials in the kitchen, it is essential to explore their merits and demerits, understanding both the promises and challenges they bring to the table. Nanomaterials in culinary science. Nanomaterials, often ranging from 1 to 100 nanometers in size, possess unique properties compared to their bulk counterparts. In the culinary context, these materials can be employed to enhance various aspects of food preparation, preservation, and presentation. One notable application is the development of nanoemulsions, tiny droplets of oil dispersed in water, which can lead to improved textures and flavors in dressings and sauces. Nanoencapsulation enables the controlled release of flavors, nutrients, and other bioactive compounds, enhancing both taste and nutritional value. Merits of cooking with nanomaterials. Improve texture and flavor. Nanoemulsions and nanocapsules can enhance the texture and flavor of food by providing a more uniform distribution of ingredients, resulting in a smoother and more appealing culinary experience. Extended shelf life. Nanomaterials can be utilized for better food preservation, reducing spoilage and waste. Nanocoatings on packaging materials can create barriers against oxygen and microbes, extending the shelf life of perishable goods. Healthier alternatives. Nanoencapsulation allows for the controlled release of nutrients, enabling the development of functional foods with enhanced health benefits. This could address nutritional deficiencies and contribute to overall well-being. Efficient cooking processes. Nanomaterials can improve the efficiency of cooking processes by enhancing heat transfer and reducing cooking times. This can lead to energy savings and a more sustainable approach to food preparation. Demerits and challenges. Safety concerns. The safety of nanomaterials in food is a paramount concern. Questions arise regarding the potential toxicity of certain nanoparticles and their long-term effects on human health. Rigorous testing and regulations are essential to ensure the safety of nanomaterials used in the culinary domain. Environmental impact. The production and disposal of nanomaterials can have environmental implications. As the culinary industry adopts nanotechnology, it is crucial to consider the life cycle of these materials and their impact on ecosystems. Ethical considerations. The integration of nanomaterials into the culinary landscape raises ethical questions related to transparency and consumer awareness. Clear labeling and communication are imperative to empower consumers to make informed choices. Cost and accessibility. Nanomaterials, especially those of high quality, can be expensive to produce. This cost factor may limit their accessibility and adoption, particularly in less affluent communities. Conclusion. Cooking with nanomaterials represents a tantalizing frontier in culinary science, offering a spectrum of possibilities to enhance the art and science of food preparation. The merits of improved texture, flavor, and nutritional content are promising, but they come hand in hand with challenges related to safety, environmental impact, ethics, and accessibility. Striking a balance between innovation and responsibility is crucial as we navigate this culinary revolution. As researchers, chefs, and consumers engage with nanotechnology in the kitchen, a conscientious approach is essential to ensure that the future of cooking with nanomaterials is not only flavorful but also sustainable and safe for all.